This is an introduction to how we can use natural language processing and transformer models to convert sentences in any language, that could be English, Spanish, French, and so on, natural languages into vectors. Once you have a bit of text that's in a natural language, let's imagine a sentence like this. How would you work out how similar to another sentence in English or another language? What we can do is we can use a transformer, which is a really smart, cutting edge kind of neural network, and we can send this sentence through the transformer model and we get a vector out of it. And then we can use that vector as you would normally use a vector in math. So you can calculate distances, and sentences which are similar semantically tend to come out as being vectors which are similar in terms of distances. So I'm importing a model from a library called Hugging Face, and this is a transformer model um, which converts text into vectors of length 768. So if I give it a single sentence, I get an output vector which is 768 floating point numbers. Where I got this language model from, by the way, is from a website called Hugging Face, which is really easy to use, really easy to work with, and they have a huge library full of language models. So the one I'm using is this one, MSTSB, paraphrase, XLMR, multilingual version 1. And this is one that I picked because it's multilingual, and when I tried it on the data that I had, it seemed to work really well. But there are a huge selection of language models here, some multilingual, some monolingual, that you'll find, sentence BERT, which converts English sentences into BERT. You'll find a Chinese one, which converts Chinese sentences. There are legal, medical domain models, all kinds of things. So now if you put a different text into that same transformer, you will get another vector. And now the obvious question is, what is the similarity between these two texts? So if I input, um, let's say, yeah, put vector 2, create vector 2, and that will be my next, the vector of my second text. I can now subtract a vector from a vector 2, if I can get this right, and I will get something which we can convert into a vector, into a distance. So look, here's the first 10 elements of my vector of my first sentence, and the first 10 elements of the vector of my second sentence. And you can see that my vectors are kind of similar, more or less, in magnitude, but still quite different from each other. So working out the distance, I can subtract the two, and that gives me a vector distance. And then what I can do is take that vector distance and sum all the elements squared, and then square root it. And that is the simple Euclidean formula for distance in multidimensional space, in Euclidean space. So these sentences are 8.75 distant from each other. The units here are not really interpretable in isolation, only in comparison to other distances in the same space. So there is not really a unit. But if you find that these two sentences have distance 8.75 and another two sentences have a smaller distance, that means that latter pair is more similar. So what I'm now going to try doing is putting in a load of sentences in English, Spanish, and German. So let's try those three languages and put these sentences into my transformer and see what they turn into. So I've got 7 sentences in total. This is how many we've got. And I've put them into a list of strings. So they're all approximately in the same domain. And now if I can pass them all through my model, and then I get a vector of length 7 height, or rather height 7 by 768 width. So I have 7 sentences. Each sentence has turned into a vector, and I've essentially got a matrix, 7 vectors. If you want to plot these in a graph, then one library that's really useful is something called TSNE. It's really good for converting vectors in high dimensional space into a lower dimensional space, such as 2D. We have a 2D screen here, and we want to plot them on a graph. So I've just tried it, and it doesn't seem to work. It's giving me an error. Perplexity must be less than n samples. So I think the problem is, normally you would have thousands of text which you throw into the model. So I think I need to set a parameter somewhere. Okay, I think I'm just searching that online. So this is typically part of the development process. I haven't seen this error before. But yeah, it looks like I need to pass a parameter called perplexity into the TSNE model. So I'll do that, add in a perplexity. And it looks like that probably was what was going wrong. Here we are. So, yeah, now that works. So now I've created a new variable z, which has has now placed each of my 7 sentences into a 2D space rather than a 768 dimensional space. So that means we can actually plot these on a graph and see where they are. Let's give that a go now. So I'm going to use this library matplotlib, and I will plot each sentence and then also annotate where they are in, so you get the sentence appearing on the graph. Now this has created a graph. Now let's see how we can show it. Here we are. So you can see at the top left we've got the chemotherapy sentence, and then we've got a German sentence, the 2 German sentences, 3 German sentences together. The English sentence and the Spanish sentence, which had the similar meaning, are actually very close to each other on the graph. So it's nice to see that the graph has done something useful. Sentences which are semantically similar have appeared together on the graph. So now the next thing we're going to try is to see how similar 2 sentences are. I'm going to create a function to get the distance between 2 sentences. So my function takes 2 string sentences as input and converts them both to vectors, and it will give us the Euclidean distance between the 2 vectors. So let's try this. Now let's try an English sentence with a Spanish sentence that means pretty much the same thing. So patients in all age groups responded well to adjuvant therapy. And then the Spanish sentence meaning the same thing. Las pacientes de todos los grupos de edad respondieron bien a la terapia adyuvante. The similarity value that we've got is good. We've got a close proximity, 2.7. That's much lower than what we were getting before. Now let's try an English sentence with a different English sentence that means something completely different. And look, we get 8.75. So these two are considered to be much further away. Now, if we edit that Spanish sentence, so it means something different, again, we are now much further away semantically. So here you can see how the transformer model really makes quite a good representation of the meaning of a sentence